Welcome to Foundation Mastery Method Differential Equation Solutions. We are taking very important example where the right hand side we have piecewise defined function, but we want to transfer that one to step function and solve the initial value problem. So let us take the example. We have the differential equation x double prime plus 4x equals sine pi t when t is between 0 to 1 and it is 0 when t is greater or equal to 1. With the initial conditions x0 equals x prime 0 is 0. So we need to find the step function from the piecewise defined function. So let me take a number line and we look at the point 0 and 1 where t is defined, 0 and 1, and then we have values of the function between 0 and 1 is sine pi t and the other side's zeros. So we write them. Now the formation of step function. So c equals 0, that's why you just write u t minus c as ut. And then second part c is 1, so we write u t minus 1. And then the derivation of the whole step function form instead of this piecewise defined function is as follows. First we are taking this ut and then right hand side value minus the left hand we write here. Then ut minus 1, the left hand will be subtracted from the right hand. So we get this. Now we write down those in terms of step functions and then use the Laplace transform. So the left side Laplace transform for x double prime will be first three terms as you have seen in the formula sheet. And the uppercase x we are writing from the Laplace transform of this one because the definition says Laplace transform of lower ft written as uppercase fs. So that's we are writing uppercase xs. And then since initial conditions are both zeros, we just end up with s square xs and 4xs. Now we need to find the Laplace transform of the piecewise defined function written in step function form. So we'll do this one separately and then plug it back. So the first one you have sine pi t ut and c is 0 here, that's why e to the negative 0 times s. Laplace transform of sine pi t is replaced by or t plus 0. And that one is giving me now pi over s squared plus pi squared. And then the second one we have ut minus 1, so that's why e to the negative c is 1, so e to the negative s. Laplace transform of now sine pi t, this t will be replaced by t plus 1 because c is 1. So we have sine pi t plus 1. If you distribute pi, then you can see sine pi plus pi t, and we know that if you consider this pi here is one rotation halfway goes to the second quadrant and then it goes back to third quadrant, and sine is negative there, that's why I put this negative sine pi t. And that one will be putting here, and then with the Laplace transform you get again pi over s squared plus pi squared because of sine bt formula. So you plug it back here, and then let's do some simplification, and we get xs equals this, and we want to separate 1 and e to the s. Okay, now we need some more space because we need to do the partial fraction decomposition here, and I show you the process. I hope you will understand the calculation. So quickly I'm just showing you how we got all this, and we are writing as a polynomial kind of s3 s square s and then constant terms. And then as you know, this is a constant one, this one will be same as pi and the rest will be 0. So then we get a plus c is 0, b plus d is 0, meaning is b is negative d, and then we have 4a plus pi squared c, which is coming from this one here, is also 0, and then this one is pi. So we just need to solve this system now here, and you get d equals pi over pi square minus 4, and b is negative d, so that's why just a negative in front. Now a plus c equals 0 and 4a plus pi squared c equals 0. If you solve, both will be 0. A will be 0, c will be 0. So now we plug it back here in this form. So now we are ready to apply inverse Laplace transform after just making a little more simplified version of xs. So I'm just putting into two forms. One has e to the negative s part and another one is just without that one. So this one will follow the step function ideas because you have e to the negative s there, but this part you don't have, so you just use a regular. So we'll be taking inverse Laplace transform. So then inverse Laplace transform of uppercase xs becomes xt now. Constant we leave it here. 1 over s square plus 2 square, we need also here here we need a b, right? So it is 2. So that's why we are writing 1/2 sine bt, b is 2. And the same with second one. Then the next is, we have this, now e to the negative s will return ut minus 1. And then again it goes with sine to t, but t will be replaced by t minus 1. So that's why all values, you can see here the same result we have. So our t will be replaced by t minus 1. That's why it becomes 2t minus 2. And pi t, so t also will be replaced by t minus pi.